Hello friends, myself Envi Lahamge, Assistant Professor, Department of Computer Science, MVP Samaj, Nasik. In this video, we will try to understand what is the epsilon closure of a state. First of all, we will see some background details like epsilon closure is nothing but it is set of states. It is nothing but set of states. Suppose we will call them as a P, such that there is a path from Q0, means there is a path from Q0 to all the states labeled by P, means which are the states of P and are labeled by epsilon. Means suppose there is a one case like Q0, Q1, Q2, Q3, and these all states are connected by epsilon. Then we have to design the epsilon closure of Q0. Then we have to find the path in such a way till it goes with epsilon, means Q0 and Q1 are connected by epsilon, Q1 and Q2 are connected by epsilon, Q2 and Q3 are connected by epsilon. So the number of states in the epsilon closure are Q0 itself, Q1 itself, Q2 itself, and Q3 itself. One key note for taking epsilon closure is that every state will come into its epsilon closure. That is, if this is the final stage and no any stage comes with the epsilon further, then in such cases the epsilon closure of Q3 will be the state itself, that is Q3 state. Now we will take one example and try to calculate the epsilon closure of different states of a one DFA. Suppose we will consider one example like Q0, Q1, Q2 and Q3. This is the NFA for every alphabetical order of elements in a string. So in this case, we have to calculate the epsilon closure of all the states. How to calculate it? We will calculate it like we have to calculate the epsilon closure of all the states. Means epsilon closure of Q0, Q1, Q2 and Q3. So here in this example, we will see that the Q0 is connected with Q1 by epsilon, then with Q2 again by epsilon, and Q3 again by epsilon. So we have to collect all the states which are connected by the epsilon series, that are Q0, Q1, Q2, Q3. These are the number of states coming in the epsilon closure of Q0. Now, what is about the Q1? Q1 is connected with Q2 and Q3 by the epsilon, directly with Q2 and indirectly with Q3 by Q2. So, this states Q1, Q2, Q3 will comes into the epsilon closure of Q1 next. For Q2, we will see that Q2 and Q3 are connected by epsilon. So, this Q2, Q3 will comes under Q2. Again for Q3, as we know that every state comes into its epsilon closure. So, Q3 will comes into its closure itself. This is the procedure to convert any or to evaluate any state's epsilon closure.